question 13 gives us this parametric equation. X is equal to root 3t squared plus 4t, y is equal to 2t cubed plus 8t. First thing we're asked to do is find dy by dx. Well, how do we find dy by dx? If we think back to parametric, differentiating parametric functions, it's the chain rule. Dy by dt times dt by dx, and we have another neat theorem that tells us that dt by dx is the same thing as 1 over dx by dt. So, what do we have? Well, dx by dt is 2 root 3t plus 4. Hold on, sorry, that this one here should be minus 8. So dy by dt will be 6t minus 8. So what is dy by dx? Dy by dx is then equal to 6t take 8 over 2 root 3t plus 4. Well, we can divide by 2, and what do we get? We get 3t take 4 over root 3t plus 2, and t squared, what am I doing? And we can see that this up here is actually a difference of squares. So this is actually root 3t plus 2, root 3t minus 2, all over root 3t plus 2, so is equal to root 3t minus 2, which is what we were asked to show. So the second part asks us to find the values of t for which the curve lies above the x-axis. So above the x-axis, below the x-axis translates to y being less than 0, right? Because if you think about our axes, here's our x-axis, here's our y-axis, this region under the x-axis is characterized by the fact that the y value is less than 0. It's a negative y value, right? So we just need to find the values of t for which y is less than 0. So y is less than 0 tells us that 2t cubed take 8t should be less than 0, or that 2t take 2t plus 2 is less than 0. How do we know which particular region we're talking about? Well, if we draw the sketch of not y against x, but y against t, we see that the curve looks something like this, where this is, sorry, I've lost my cursor, where this is 2, 0, negative 2. So we see, for this to be less than 0, we need either t to be less than negative 2, or t to be between, not equal to, t to be between 0 and 2. So the last thing we're asked to do is find the area for this curve between, so this one will be rejected. So it asks us to find the area of this between this curve and the x-axis for these values of t. So if you think back to the previous question, we know that the area of between a curve and the x-axis, so our area, is always given by the integral from x equals to a of x equals to b, absolute value of y dx, right? But again, this time we don't have x as a variable, we've got t as our variable, so we change it. We're looking for t between t equals 0 and 2 of absolute value of y dx by dt dt. What does that give me? 0, 2, absolute value of 2t cubed take 8t. Dx by dt was 2 root 3t plus 4. 2 root 3t plus 4 dt. And the critical thing is, we know between t equals 0 and t equals 2 that this expression is strictly negative. So what do we get? We actually get a minus sign for the absolute value function. So I'll just bring that out the front, and then we get 2t cubed, take 8t, 2 root 3t plus 4 dt. So actually, if you expand this out, this is just a polynomial, or you can use your graphing calculator to help you out with the evaluation of it. But what you get after a while is you get 32 1 plus 8 root 3 over 15 units squared.